right, well, good evening, ladies and gentlemen. Thank you very much for coming out on a Friday evening. Welcome to Union Station's wonderful Browning Theatre. My name is Dan Bedford. I'm a professor in the Geography Department up at Weber State University, and it's my pleasure and privilege to introduce this evening's speaker. Before I do that, I just want to identify a couple of organizations and people who've really contributed to making this evening's event possible. First of all, the National Academy of Sciences, who's provided financial support, and also the Sustainability Practices and Research Center on campus, SPARC, which has provided amazing logistical support and really gone the extra mile to make this event a success. So thank you very much to both of those organizations. I'd also like to mention that SPARC, the Sustainability Practices and Research Center, has a table with a sign-up sheet. So if you're interested in these kinds of issues and these kinds of events, you can sign your name up and you'll get emails, notification about future events like this. So about today's speaker, about this evening's speaker, Dr. Richard Alley. Apparently that's all I need to say. Richard Alley is Evan Pugh Professor of Geosciences at the Pennsylvania State University, and he's the 2014 recipient of the Arthur L. Day Prize for Science Communication from the National Academy of Sciences, among many other awards and accolades. He's published some 260 peer-reviewed scientific journal articles, as well as 2 genuinely riveting books about climate change for a popular audience. He has appeared in numerous TV documentaries, including Earth, the Operator's Manual, which is, in my opinion, required viewing for anyone seeking to understand climate change and what we can do about it. And it's available online, and the web address is easy to remember. It's www.earththeoperatorsmanual.com. His scientific work is focused on understanding the climates of the past using ice cores retrieved from Greenland and Antarctica, and some of his more important findings have included the realization that climate can change very quickly. This evening, Dr. Alley is speaking about the good news about energy, the environment, and our future. Please join me in welcoming Dr. Richard Alley.
Oh, thank you. So I was told that I am supposed to be up on the stage because you can see me better, so please do not consider that I'm looking down on you. The first time I ever testified at a Senate subcommittee, they put the senators up here and the testifier is down there, and the chair is sort of low, so you're always look. Anyway, please don't think we're doing that to you. It is my honor and privilege to be here. We've been having a very, very good time, a little bit too short, but that's life. And I do want to walk you through what is ultimately a good news story, but I intend to scare the pants off of you on the way. So with that, I want to thank Dan for the hospitality, a nod to Jeff Haynes Styles, Earth, the Operator's Manual, and very clearly thank you for coming out. This is a testament to the community here in the forward-looking way that you have here. So with that, and also thanks to the National Academy of Sciences, you will have a little reception later, and it's on them. So, okay. So in case you have to leave early, you'll miss the reception, so you don't want to do that. But the skinny version, what we're going to get to in the end, is that we actually use what we know on climate and energy, together with what we care about and where we want to go. Not only does it help the environment, not only does it honor the golden rule, but it helps the economy too. And so that's where we're going to go. But I want to take you on a tour of just how valuable energy is to us. Just how much we owe to the people who are getting us our energy, and then how we move on to even a better future than the one we have now. So I'm going to do this through walking through a story of the value of energy, the value of building and engineering and inventing, and I'm going to do it just south of you down here a little bit. So I teach this big online class. We have 1,100 students spread all over Pennsylvania and around the world. And it's Geology, the national parks. So you do Geology, the national parks, what do? We got a dozen advanced students. We got our local PBS affiliate to teach them how to film. We took them to the Grand Canyon. We took them to Bryce and Zion. We just had a ball. And so here they are. This is Grand Canyon, but you know, we actually got to the bottom of the canyon by moonlight, and you know, it's just, you just can't imagine. You know, Bryce was so much fun, and Capitol Reef was really good. Here Stephanie is explaining to our film guy Topher why the Colorado, which once was too thick to drink and too thin to plow, why it now is perfectly clean. And you all know the story. It's because the mud is behind that. And so here we are rafting down the river. And so this is Geology, the national park, so we're doing geology. But, you know, you're driving right by Mesa Verde. And you can't drive by Mesa Verde without stopping. And so we went there, and we had a tour. A wonderful ranger gave us the really best thing. And I'm going to tell you a little bit of what we saw there. Now, I want to be very clear. Later, I'm going to say, look, CO2 is a greenhouse gas. CO2 is a greenhouse gas. This is physics. There's no ands or buts there, okay? I'm going to tell you a story about people. I will guarantee you that the reality is more complicated than anything I can tell you, because people are never as simple as a simple story. But what I'm going to tell you is what the ranger told us, and I believe it is accurate. So we're going to walk through what we saw in Mesa Verde. So if you haven't been there, I presume most of you have. If you haven't, go. It's really a wonderful thing. And so here we are in Mesa Verde, and you know, they grew corn up on top, and they lived in these natural caves down on the side, and they built, you know, these beautiful pueblo, and there's some in southern Utah and other places here, as you well know. Here's a ladder, and what we want to look at for a minute is that. So you'll notice here's the housing down here, and then there's this cliff, and up there is food storage. And here's another view of it. So there's one of our students is down in the very lower left for scale, and then, you know, up here is food storage. Now, why would you put the food up there? And the probable answer, there may be a few of you understand this. I am now a little older than I used to be, and maybe a little more careful about what I eat. And if you ever had a package of Oreos, and you said, you know, I really shouldn't eat the whole package of Oreos. And if I put them way up on the top shelf and I put the ladder away, maybe I won't eat the whole package of Oreos. The difference is that for me, that's the Oreos, and this was dinner. This was the main course, and they're putting it up on the shelf where it's really hard to eat before you get to it. And that's a little more concerning. Now, these are built-in caves, natural caves on the side there. The water goes through the sandstone, it hits a shale parting, it comes out, and it makes the cave. And so this is around, if you go behind there, right back in there someplace, and you look, you see this. And there's a little bit of water seeping out there, and you can see where the plants are. And right down at the end of the blue arrow, if you go and look, what do you see is this. And you see here and here and here, somebody sat there with a rock and chipped a hole. And the water that seeps out collects in that. And there's a little puddle of water there that you could scoop out. And I can tell you, we had iced tea with the lunch today, and this is not nearly as good as our iced tea was. But if that's all the water in the world, it's pretty good. And these are interior walls. And you can see that they were built as a wall with a window, and then the window has been blocked off. So somebody went to an effort to block the window. But what's on the other side is their neighbors. And when you block a window, you're usually trying to keep something out. And if you go there, you walk over the top, and when you get to the edge, you pass this. And they built this. So this is 1,000 years old or something like that. And so you're stopping erosion, and you make a little puddle of dirt, and that was a cornfield. And, you know, if you're really hungry, you could grow food almost anywhere, and there's a little bit water trapped here and a little bit of dirt trapped here, and you got a cornfield. And then, you know, after centuries and centuries of this being home, they left. And they probably migrated down along the Rio Grande, but so they live here in this place, and it's very, very clear when you look at this that at the end, life was really hard. And then they left, and this had been their home for centuries. Right? Now, if you look at the ruins, there's a little bit of wood, not much, but there's a little bit of wood. And so there's one log right there, and if there's wood, there are tree rings. And if there's tree rings, my community, not me personally, but my community can do science on them. And in this particular place, when it rains, the trees are happy, and when it doesn't rain, the trees are unhappy, and the thickness of a ring then is a rain gauge. And you probably know you can take living wood with its pattern of thick and thin rings, overlap it with dead wood, overlap it with wood from archaeological sites, and make a record which is longer than the life of a given tree. And so you have when it happened and how well it grew sitting in the trees. So this is not the place to do the study. Mesa Verde was a big place. There's a lot of trade. It's important. But what a couple of teams of scientists did is they went, if you're in Mesa Verde, you can almost look down the road towards Longhouse Valley in Arizona. And so they went down to Longhouse Valley, and they did a tree ring record. And they found out how much did it rain over time in this place. And then talking to people who talk to people and learning about people, the question was, how much corn can you grow from this rain? How many people could that corn support? And so you go knowing about Puebloan people, talking to them, working with them. You take the tree rings, turn it into rain, turn it into corn, turn it into how many people could live here on the corn they grew. And that gives you a history over time of the carrying capacity in this particular lifestyle. At the same time, an independent team using independent techniques is going in and doing the classical archaeology and asking how many people lived here based on the traces they left. So you have two records. How many people could based on this lifestyle? How many did based on what they left behind? And then you ask, how do these look like each other? And there's a little bit of model twiddling and what have you, but the bottom line is about here. And so over here is the year 800. Over here is the year 1300. And it doesn't matter which curve is which, because within the uncertainties, these are the same curve. How many people lived there and how many people could live there are running together. And so what do we have? The rains came and the people could settle here. And then when the rains drop, either they quit having babies, or some of them left, or their babies died. There isn't a third choice. And then the rains came back, and then you hit the big drought at the end. And yeah, a few people could have hung on, but they said, screw it, we're out of here. And they became environmental refugees and disappeared. And so this is sort of an amazing story. It's a very sobering story to think what this meant for people living there. All right, now, let me tell you the same story with a different ending. 1930s, there's a dust bowl in Oklahoma, and you remember the tales of the Okies headed for California. We can't hang on there anymore, and so we're going to get out of here. But there's a difference in this story now, because there's a drought, and people are leaving, but there's trucks, and there's trains, and there's power. And some people leave, but some people stay and food arrives on trucks and trains. And some people drill wells and pump water out of the wells. And now it is a different story. And so you see Oklahoma with its dust storm, but you also see ways that you could use to pump water out of the ground to water a truck garden. And this is the same plot as I just showed you, except this is for Oklahoma. The year 1900 is over on your left. The year 2000 is over here on your right. The red is the Palmer Drought Severity Index, but you can think of this as rain. And down here is dry. This is the Dust Bowl right there. Okay. The black is population. The truth is, the Dust Bowl did almost nothing to the population of Oklahoma. It had been growing rapidly, and it quit growing. The dip is actually World War II. People going off to save the world. And so what happens when the drought hit Oklahoma? The growth stopped. These people went to California, but in fact, the population hung on. Now, I can guarantee you that there were a lot of smart people in Oklahoma figuring things out, but I can guarantee you there were a lot of smart people at Mesa Verde figuring things out. And if you dropped us in all our glory on top of that mesa at Mesa Verde with what they had as tools and ask us to get through the winter, it ain't happening. This was a case with really smart people in Mesa Verde who failed, and really smart people in Oklahoma who didn't. And the difference really is having the tools, having the power, the energy, and having the knowledge to do it. And as we've learned, and as we've built, and as we've passed on to our children what we have learned and built, we have increased the carrying capacity of the planet a whole lot. It is reasonably likely that if we went back to being hunter-gatherers, the world would support no more than a few million of us. There are a few billion of us. And we get there by growing and building and learning and teaching and getting along with each other. And just how good we are is really easy to forget. I have a cell phone in my pocket here. You probably have one too. Mine, it's a fascinating thing if you ever want to do this. Go in a school class somewhere and pull it out and say, okay, so what is this? And they'll say, a cell phone? And the ones up close will say, it's a little old cell phone. You're not very cool, are you? And then you say, what's it made of? And you'll get this long pause. And if there's somebody really sharp, they'll say, cell phone parts? Right? What is it? It's sand for the glass and for the silicon and the chip. It's oil for the plastic, and it's the right rocks, the ones with copper in them and the ones with rare earth elements and things like that. This is sand, oil, and rocks, right? And science and engineering and design and marketing. And if you took the right sand, the right oil, and the right rocks, and you gave them to various groups of persons, the U.S. Senate, and you said, turn this into a cell phone. Okay, you know what would happen. I hate to fill this in. But, you know, we were talking about this earlier today. Einstein is in here. The GPS, which was an Air Force project, has relativity in it. And if it didn't have relativity in it, it would drop you in the Great Salt Lake in about 2 days. It would get lost. And Bohr and Feynman are in there in the quantum mechanics. And the quantum mechanics in that overlaps the quantum mechanics that we're going to do later on radiative transfer. So at any rate, it's worth keeping the idea that we are where we are successful as we are, because we have learned and we have taught, we have built, we have shared, and we've gotten along with each other. And those are not optional. And we go without these, we're not here. Okay? So I'm going to walk you through some issues, and I'm going to lean heavily on the issue of sustainability. Sustainability is so much. It is food, it is water, it is phosphorus for fertilizer, but it's probably energy more than anything else, because if you've got enough energy, you can take salt out of water and you can pump it somewhere. And if you've got enough energy, you can go concentrate phosphorus and put it back on the fields. The UN said food and energy are the two biggest issues of sustainability, but a lot of food is energy. So I'm going to walk you through the energy story. Okay? So we'll do this. I'm not sure what is in the reception. I know that I ate the whole lunch and there may be dinner yet, so I'm probably over my 2,000 calories today. Human diet calculated when they do how much should you eat is 2,000 calories per person per day. The food was cooked, after it was refrigerated, after it was trucked to us, after it was grown with a tractor. You take all the energy that goes into lighting us and heating us and moving us around and doing our food and everything like that. You divide it by the number of people in the country, you convert it to these archaic units, and it is 240,000 calories per person per day. What you can do for yourself is 2,000. What is done for you is 240,000. That is a really important number. It is like each of us has 100 serfs to do our bidding or more. Serf plow for me. Serf cook for me. Serf pick me up and fly me across the country. Serfs don't fly across the country very well. And we love this. It is fantastic. If I keeled over up here right now in front of you, you'd have an ambulance here, you'd have a machine, you'd get me to the hospital, you'd take care of me. This is fantastic. And right now, it's about 85% fossil fuels. So we are here and we are happy because of the energy we are getting out of these things, okay? Now I'm going to walk you through this history a little bit. We have a very long history of being hunter-gatherers of energy and hitting energy crises. And we find something that we can burn to get energy from. We burn it way faster than nature makes more. We start to run out, we have a fit, and then we try to come up with something better to do. And while we switch from being hunter-gatherers of food to growing our own, so there's a lot more of us, we haven't switched from being hunter-gatherers of energy to growing our own. And so I'm going to walk you through this story a little bit. I come to you from central Pennsylvania. I have little Nittany lions on my tie, okay? Our campus, called University Park, is next to a town which is called State College, and State College is a suburb of Penn State. And that is a fact. It is a suburb of Penn State because when Penn State was founded, State College did not exist. State College came after Penn State. Penn State was founded up the hill from the iron furnace. The east was built of Juniata iron. The east was built of people turning red dirt, flux from limestone, and charcoal into things that we could use that were useful. And all over Pennsylvania and surrounding areas, they put up furnaces like this one. When the furnace was working, it looked more like this one. This is Hopewell Furnace. I was there a couple of weeks ago. And so it is, you know, they're loading in the charcoal here, the ore and what have you. There's a water wheel to run the blast, and they're turning that red dirt into valuable things. This would have had lots of people taking care of it. In total, maybe 100, 150 people in a community running around this. And it's fired by charcoal. And they got the charcoal like this. You cut the trees and you make a big pile of trees, and then you bury them in dirt. And, you know, they're big things. And after it was buried in dirt, you burn it, and you're holding down the oxygen, and you're driving off the stuff, the water and what have you. If the dirt cracked, somebody would have to climb up over that fire and fix it so they didn't lose it. And this is turning trees into fuel. And what it did is this. So here's the next bit of charcoal, but what comes next? Running a furnace in blast for a year took a little over half a square mile of trees. And there's 100 people living there, and they have houses, which they built, which have trees, and they have fires, which they cook over, which use trees, and they are heating it, which uses trees. And so you can figure that a furnace in blast and the people with it took a square mile of trees per year. Now, if you go to a map of Pennsylvania today, and you ask, where are the place names that are still on the map that say furnace? Okay? These are the furnaces. There's a lot missing from here because there's a bunch of furnaces that have dropped off the map. Each of these, when it is working, is a square mile of trees a year. These are forges, Valley Forge and others. They take the pig iron and they'd run it to the forge and turn it into valuable things, another square mile of trees per year. And you know what happened? The trees went. And so I'm from Pennsylvania, Penn's Woods. When the first European settlers got to Pennsylvania, they said that a squirrel could go up a tree at the Atlantic coast over there in New Jersey and stay in the trees to the Mississippi. The first forester of the Commonwealth, Rothrock, who had been a professor at my university about 1900, wrote about the Great Pennsylvania Desert. Now, it wasn't a desert, but there were virtually no trees left in the entire state of Pennsylvania. We now have in Pennsylvania about 1 million deer. There were virtually none. We have elk because we re-imported them from the Rocky Mountains, but we drove them out. We drove out the bison. We drove out everything bigger than a rabbit, pretty much. We are the Nittany lions. There's no Nittany lions. There was nothing to eat, and there wasn't a tree to do it behind. And the whole East did this. Basically, everywhere you go in the East, the trees went. It was really early in some places. In the 1600s, out at Eastham on Cape Cod, they were already outlawing your own ability to cut your own tree on your own property because the ravages of deforestation were so extreme that the government was getting in people's faces. The crisis hit and they had trouble. Now, if you've ever tried to read by firelight, it's not very easy. If you've ever tried to do 12 stitches per inch on a quilt by firelight, it's not very easy. And so what did they do? Poor people could use candles. That's not much better. They used to use a biofuel called camphene, which is a mixture of alcohol and turpentine. It burns cleanly. It's fairly cheap. But it's really flammable. It's not quite Coleman fuel, but you know, you get the idea. And you can find these horrible stories in the old newspapers of, you know, the Methodist minister and his wife go out to visit the parishioners and they leave the 3 daughters behind, and the daughters try to refill the lamp and it blows up and they burn to death. And the rich people used to burn whales, or whale oil. You would send Yankees out of New England to scour the world ocean for whales, and they'd cook them and they'd bring it back and you'd put it in your lamp, and it didn't blow up and it didn't stink and it burned cleanly, and it cost a fortune. So this is the history of whale oil production in the Yankee fleet. 1800 is over on your left, 1880 is over on your right. This is a very complicated curve. There's a civil war in here, and they sank some of the ships off of the Charleston Harbor to try to blockade it. There's the fleet getting crushed in the sea ice off of Alaska and the insurance rates going through the roof. But what was the fleet doing in the sea ice off of Alaska? There weren't any whales they could catch that were closer. And you see the history here. There's peak whale oil right there. The price, they drove it down as they worked harder and harder and got smarter and smarter. And when peak whale oil hit the price, this is $7 a gallon in modern money. It went up to $23 a gallon in modern money. And then what happened? They went right up the road from me where oil leaked out of the ground, and they said, wow, oil leaks out of the ground. Maybe there's oil in the ground. And they drilled the first modern oil well. And it's an amazing thing. Now, at the peak here, there are 10,000 sailors out of New England on ships scouring the world ocean for whales. 10,000, right? And in that 100 years, with 10,000 sailors at the peak, they collected enough oil to equal about a week of recent U.S. oil imports. The idea that somehow when we run out of oil in the ground, we just go back to what we used to do is completely laughable. It's impossible. Right? So, but be clear. We have whales and trees because we burn fossil algae and fossil trees. And they knew this way back then. So if you can't read this from the bottom, this is an editorial cartoon. It was published in the magazine Vanity Fair in the year 1861. And this is the grand ball given by the whales in honor of the discovery of the oil wells in Pennsylvania. Okay? This is right before the Civil War. So it's the oil wells of our native land. May they never secede. Oil's well that ends well. Right? We have whales and trees because we burn fossil fuels. And that's true, right? And we cannot keep doing this. Now, whether it's in my lifetime or whether it's in our students' lifetime that we get into trouble is still not clear. We have been very, very clever at finding more. But in round numbers, Scarcity is coming. We are burning these. They accumulated over a few 100 million years. We are burning them over a few million years. We are burning them about 1 million times faster than nature saved them. The rate at which new ones are being formed is so close to zero that you can think of it as zero. There is a bank account, and that's it. As I said, the first modern oil well was drilled where oil was leaking out of the ground. Okay? Some of you are old enough to remember when our television had a situation comedy about our energy system. Right? You remember this. It was a story about a man named Jed. And he was a poor mountaineer, and he barely kept his family fed, and one day he was shooting at some food, and up through the ground come a bubbling crude. Oil, that is, right? And they could do this because oil used to be pretty easy. What is BP doing out in the Gulf? The easy stuff isn't there. There's little tiny bits hidden in parks, but not much. Not much. Why are we fracking and other things? Because the easy ones are good. There's a lot of hard to get to yet, but the easy stuff really is gone. And so we have to, it is not a choice. Just get it out of your head. There's not a choice between renewables and fossil fuels. We either learn while we burn, or we burn and then learn. And if you take the top off the mountain, you're going to have to put a solar cell on that afterwards because the fossil fuel is gone and it's not coming back. And so there really is not a choice here. Now, this is where the other piece of this story, I showed these next 2 or 3 slides today, but I'll do them again. CO2 is a greenhouse gas. We put 20 tons per person per year into the air in the U.S., just a shade under, but not much. Okay, that's a lot. And it is a greenhouse gas. And we have known this for well over a century. And as I explained at lunch to those who were there, a lot of the physics was worked out by the Air Force right after World War II. The Air Force was not doing global warming. They were doing things like heat-seeking missiles. So there's a heat-seeking missile. If your job is to keep the enemy from bombing your city, one way to do it is this will follow the hot exhaust of the enemy bomber. It will fly up their tailpipe and make sure they don't get to you. That is infrared radiation from the hot exhaust. But if you put the wrong sensor on, you can't see it because the infrared is soaked up by CO2 or water vapor, and they transfer it to the other molecules in collisions. And rather than a hot spot you can follow, there's just this vague glow. And it's just physics. And it's physics that is used every day. It's physics that helps us in many ways. Today, the sun warmed the Earth. The Earth sent energy back to space. This is a satellite image of the energy going back to space. This is what didn't make it back to space because CO2 in the atmosphere absorbed it and transferred it to the other molecules around it. And this is what would be absorbed if there were more CO2. It is absorbed, that's observed fact. Actually, there's 2 curves on this because the absorption is increasing. And as we erase CO2, more can be absorbed. You will routinely meet people who say, do you believe in global warming? It's sort of like asking, do I believe in gravity? It's almost that confident. If I drop this, maybe it won't fall down. Right? If a tornado blew the roof off at the moment I dropped it, it could suck it out of my hand. If you had embedded a secret electromagnetic in the roof and you turned it on at the right moment, it would go up. If the earthquake happened and the whole stage dropped out from under me, you would see it hover for a moment in the air. But you know what would happen if I dropped it. CO2 is a greenhouse gas. Okay? And so and yes, you can find a scientist who will disagree with me. We scientists love contrarians. I could find you somebody that would argue about Einstein. It's working in your GPS, but I will find you some. We could probably find somebody who would argue about continental drift and earthquake faults. But there is a middle. And now, just a little bit of a side for what it's worth. We have found ways over long times to allow us scientists to argue while getting the best information for the public. And in the case of the U.S., we have the U.S. National Academy of Sciences. This is founded by Lincoln. The House, the Senate, and the President in the same day say we need the scientists to step out of their arguments, come out as volunteers in the public eye for the public good and tell us what is solid, what is speculative, and what is just silly. Okay? The first report they ever did, second, was how do we make the compasses work on the ironclad ships now that we're having to put giant slabs of iron next to our compasses. They fixed it. Okay. Wilson said we do the academy. Bush Sr. said the academy is our advisor. Bush Jr. said the academy is our advisor. Bush Jr. asked the academy to convene a panel that included the most prominent skeptic of climate change, and they all sat down together and said, yeah, we're changing the climate. Right? There are ways to do this, and so when in doubt, you go to the people who are doing this very, very seriously. And so this is the National Academy of Sciences, National Academy of Engineering, National Academies of Medicine. If you need good information, this is not sexy. This is not the latest thing. This is after it's been well digested. But if you need good information, that's your starting place. And most of the members of our government know that this is what they set up, and they still use it. In England, they use the Royal Society, and there's various other such bodies around. And they have been so consistent over decades and decades in telling the same story. We are changing the atmosphere. That will affect us. Okay. Now, if we had a semester, we would go over the whole story, because there are a whole bunch of links from more CO2 is making it warmer to what does that do to the climate, what does that do to us, what does that do, so on. But the very skinny version, yes, we are raising CO2, very high confidence. It is us. This has a warming influence from physics. It is getting warmer, despite the fact that over the last 30 or 40 years, the sun has dimmed a little bit, and we have blocked the sun with particles, and volcanoes have blocked the sun, and we have cut some dark forests in places and replaced them with more reflective grasslands. And so despite nature and us trying to cool it off in other ways, it has been getting warmer. And that warming has the size and the shape and the arrangement that we expect from the CO2 and the other things going on. This confirms our understanding with very high confidence. And that shows in turn that if we frack it all, if we take off all the mountaintops, if we do the oil shales, we can cause a lot more warming than we've had so far. Okay? Now, nobody cares, right? Big whoop, global mean surface temperature. Okay, what does it mean for us? There's a number of pieces of this story. Sea level rise is virtually unavoidable. Tropical diseases, you don't have to get malaria, but one of your lines of defense goes away. If you're trying to keep rare and endangered species in your beautiful national parks and the climate changes and they need to move 1,000 miles, how do they get there when we're in between? We may even have fewer hurricanes, but the ones that form have more fuel so they can get bigger. Probably, this one's weird, more floods and more droughts. The rain comes harder but flashier in shorter periods. All winter, my tomato patch is going to be either damp or frozen. In the summer, I have a downpour, and 2 weeks later, I have to water the tomatoes. So more variable in a more summer-like world. We'll come back to this. Crop heat stretch, grain belt drying, really important. And this one will also come back. Each degree of warming costs more than the previous degree. Okay? So let me walk you through this one. This is a paper that was published this past summer. This is one paper, but it agrees with a lot of other scholarship more broadly. And if I zoom in on those pieces and blow them up for you, drought contributed to the conflict in Syria. Syria was a very unhappy place, but it wasn't as unhappy as it is now. And drought hit, and the farms failed, and they didn't have the wherewithal to do what some of the Oklahomans did. And a lot of people did migrate, and they migrated in the cities, and unhappiness followed, and now we have ISIS or ISIL, and we have civil war, and we have refugee crises, and all sorts of things. Did humans cause the drought? We made it more likely, and it happened 2 to 3-fold. So you can't say, yes, we caused that drought, but we loaded the dice. And it's been very clear for a long time that the changes we're causing will tend to dry out the subtropical dry zones. And so this is a projection for the future. If we keep burning, what happens to drought by the time our students are getting older. And green is less drought. So if you're up in Siberia, you're up in Alaska, you know, that's okay. But not that many of us live up in Siberia and Alaska right now. And if you're over here, or you're over here, or where a whole lot of us live, you will notice that there's more drought. And in particular, if we zoom in on a place where drought is already causing some real troubles, you'll notice the coloration there is more drought. Okay, that's a big deal. Our military leaders are getting this very clearly. This is from a report of the CNA Military Advisory Board, a bunch of retired admirals and generals. You will also find this in the Quadrennial Defense Review of the active military. And they're very clear. They say, do not, for a minute, say that climate change caused a civil war. Civil wars have lots of causes. And there are times and places that people hit big droughts and they just work right through them, the way they did in Oklahoma. Oklahoma did not have a civil war. But if you have an unhappy place and you make it unhappier, that's not good. And so they have actually traced the dotted or dashed line between drought and civil war in Syria, heat and drought in Russia and China to the crop failures that preceded the North African uprising, and with the fair likelihood that we contributed to these changes that have already happened. And so they say climate change alone did not cause the conflict, it certainly added environmental stressors. Okay. This one came out from a group associated with the World Bank a small number of weeks ago. It was actually about 3 weeks ago, so I need to update that. But climate change could force more than 100 million people into extreme poverty by 2030. This is another interesting study in the last few weeks, which tried to look at how economies respond to temperature. If you're really cold, warming may help you. If you're really warm, warming doesn't. Blues up here are actually people that, according to this study, would be slightly better off in the warming we're facing over the next decades. Again, there's not that many people live up there. The pinks and the reds are people who are already on the warm side of optimum, and when it gets warmer, it hurts them. So if you wonder what's the best temperature, it's somewhere more or less where we are now, and warming then when pushes us away from that. And you'll notice this. There's a lot of people live there. And so here is a different way to look at this. And this one is fairly serious, I think. The redder you are, the more CO2 per person per year. So red is per person changing the climate. And you'll see where the red people live, one there, but mostly it's rich people in cold places. Blue is not changing the climate very much, poor people in hot places. This is a measure of how vulnerable you are to the warming, how steeply your economy goes down when it gets too hot. And what you'll notice down here at the bottom, I hope you can see it, is this band of red here, and we're more in blue. And so you put these two together, and if these two don't look like each other, and you believe in the golden rule, there's an issue. And you've seen many leaders of faith of many different denominations who have looked at this. Pope Francis has recently been vocal on this, and in September he said, "It seems clear to me also that climate change is a problem which can no longer be left to a future generation. The winners are rich people in cold places burning fossil fuels now. The losers are future generations and poor people in hot places now." And the Pope wasn't happy about that. Just in case you're worried about you, blue is less drought. This is a different study, but it's sort of the same story. Blue is less drought, browns are more drought, so you can do you in here, and yeah, it's there you go. Okay? And then we come back to this one, which is the first degree of warming. We're used to a variable world. We've handled variability before. 1 degree, not that big. Now remember, 1 degree is 1 degree Celsius. It's 1.8 Fahrenheit, and the land warms more than the ocean, so it's 2 or 3. But so that's what we've used. It's a 2 or 3 F on land. But we've dealt with variability. And so we aren't hurting that much yet. You're still here. You're still doing okay. But we've used that one. The next degree starts to move you out of what you're used to. But, you know, if your crop doesn't work anymore, you can borrow one from a warmer place. But that one's the one we're committed to. And it's really hard to stop before that one. We're arguing now about 3, 4, and 5. And again, the land warms more, so 10 or 15 Fahrenheit on land, things like that. And now, a lot of the world, right now, there isn't a crop that likes it warmer because there's nowhere warmer. And so you start moving out of what you're used to, and then the costs go up a lot. So each degree costs more than the one before it. And, you know, what's the worst thing that could happen? Well, it gets really, really hard to live in those hot places. Okay. So this is, we also chatted about this. This was essentially the key point of this afternoon's talk. Uncertainty is not our friend. You'll hear people say, oh, well, you're not certain about that, so shouldn't we wait? Okay. You know, with very, very high confidence, that I can't build my cell phone with a hammer, but I can break it with a hammer. And you know that you couldn't build this beautiful train station with just a hammer, but you could break it with a wrecking ball. Building is hard, and it takes getting a lot of things right, and breaking is a lot easier. And so when you ask, is there a reasonable chance that by just cranking up CO2, we will turn the planet back into the Garden of Eden, the answer is no, because that takes getting a lot of things right. Is there a chance that we will break things that we care about very deeply by 20 tons of radiatively active gas per person per year to change the climate? And there is a chance. And so we walked through some of the tipping points, some of the things that could break in the future. And, you know, and the worst chances really are things like it gets so hot in the tropics that if you go outside, you're going to die. Right? It's like getting locked in a hot car on a summer day and not having an air conditioner and not being able to get out. There's nothing you can do. We don't expect that this century, but by very late in the century, in a few places, it might be coming. And long before it gets there, it gets really hard to work outside. Okay? Now, I hope I got you scared at this point, because this really is the scholarship. I'm not trying to spin anything for you. But there's this additional piece, which is if we take this, and we take what I'm going to show you in just a moment, and we take our commitment, and what we care about, and where we want to go, and we put all those together, and we look to work to the future together, it is quite clear that we end up with a stronger economy. That economy has more jobs, it increases national security, it cleans the environment, and it honors the golden rule. And so this is where we want to walk now, is what is the possibilities for solving this. Okay? So can we do this? Yes. Yes, 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 yes. So 2,000 calories per person per day, where does it come from here? Up here on top in orange is where we grow our food, crops. The oranger it is, or the darker it is, the more of the land area in that square is used for food, and all that orange area is where we grow most of our crops. There are things in the world that we can't farm easily, but if you grow grass, you can have cattle or goats or sheep or something eat the grass. You can eat the cattle or the goats or the sheep, and so you can get food that way. And so down below in the yellows are where we have gotten our food by grazing. We have changed fundamentally everything in color here to give us that 2,000 calories per person per day times the 7 billion of us. Suppose I was hearing about solar power coming to Weber State and elsewhere in Ogden today. Suppose that we decided, with existing technology, to build a solar farm that would supply humanity more power than we now use, more than all that's used on the earth, with what we have now. And for the sake of illustration, I'm going to put it in the Sahara Desert. Clearly, no one would build your power in the Sahara Desert. You're going to build it over your parking lot up here. But at any rate, if I put that in the Sahara Desert, how much area is required with existing shovel-ready, on-the-shelf technology to do this? And it's this pink square. Okay. This is where we feed ourselves. that would power us. Now, don't kid yourself. That's one heck of a lot of solar cells. And there's a lot of wires going to come out of that, and there's some batteries, and there's a whole lot of learning, and there's jobs, and there's inventions, and there's new companies, and, you know, that is not an easy thing. But just get the scaling. The valley floors of the desert Southwest would just about power the world. Okay? So yeah, this is doable. Now, this one, I like showing this. In our TV shows, we had some Texas ranchers. Some of them may not believe in climate change, but they believe in wind. And so, and this is, it is part of us. Before he's elected president, Abe Lincoln is on the stump giving a speech about learning and invention and patents and engineering and science. Abe Lincoln is the only president who held a patent for his own invention. And at some point, Abe says, you know, consider Illinois. Funniest thing, he's from Illinois. He says, you know, across Illinois, the wind is an untamed and unharnessed force. And quite possibly one of the greatest discoveries hereafter to be made will be the taming and harnessing of it. And we went and did it, right? And so you know, if we did this, a wind farm on the windy parts of the plains and deserts of the world would supply far more energy than humans now use. These Texas ranchers have put about 5% of their land into these wind turbines. 95% is left for what they used to do with it. But very often, these things pay better. They call it mailbox money. You go out to the mailbox and you get money. And this is $5K a year, and that's another 5, and that's another 5. And all of a sudden, you know, there's $20K a year sitting in that picture. I tell you, this is not $20K. Okay. And it's to the point now that as part of a business solution to equalize loads, there are customers in Texas who, if they run the dryer at night, it's free. They do not pay for electricity. There's so much wind on the grid that they can give it away. Right? So, hark back, the world was probably overpopulated with a few million hunter-gatherers, and we learned how to farm. And we learned how to clean up after ourselves. And we learned how to build things and give them to our children. And we learned how to get along with each other. And now there's a few billion of us. And yet we're still hunter-gatherers of energy. And every previous generation has recognized the value of energy, and they haven't known how to get off the treadmill of burning something faster than nature makes more, running out, and then trying to find something new. We're the first generation in the history of the world that can say we know how to fix this. We know how to build an energy system that will give us what we enjoy, that we can give to everybody else. If you're in a country that doesn't have coal and oil, you probably do have sun and wind. And if you're on the coast, you have some waves and some currents, and underneath you there's some hot rock that you can get some geothermal out of. And we're the first generation that knows how economically to build a sustainable energy system. And the scholarship is very clear on this, that if we go together, we go where we want to go, but we make policies that use and honor this knowledge, that we can build a bigger economy as well as a cleaner environment. And it's really an optimistic thing. And so I'm going to leave you with a picture I took in Greenland many years ago. This is real. Can we have a world that actually does have rainbows and icebergs? Of course. Thank you for inviting me. So I believe we can do questions. So we have a couple of mics up here. Dan has one and I have one. And so if there's questions and you can get very close to us or we can come to you, we will happily entertain them. Yes, one right here. We'll start off. Hang on.
So we hear a lot of people arguing about whether climate change is true, important, powerful people in this country particularly, all right? And the argument always goes the way, oh, well, science this. But really, it seems like they're all motivated by the fact they think it's some left-wing conspiracy, they think it's going to ruin the economy, and it's going to increase government control over the country. So how do we counter those arguments?
Okay, so the first one of the left-wing conspiracy, if you haven't seen it, there was a testimony in Congress earlier this week by a colleague of mine, Rear Admiral Tetley. Rear Admiral Tetley used to have the best business card on earth, right? He was in charge of the Naval Observatory, so his business card said Navigator of the Navy. Okay? It is really, really, really hard to listen to Rear Admiral Tetley describe the science of this and say, wow, that's a vast left-wing conspiracy. Okay? I have briefly identified that if we take wise policies, that we actually help the economy. And the government control one, now let me do two things very briefly. One is when crisis hits, governments get intrusive. So this story I mentioned briefly, my wife's extended family loves to vacation at Cape Cod. My wife's parents were school teachers in Cleveland, but the extended family has a little bit of property on Cape Cod. And they go to Eastham, and Eastham is right there. Okay, when the Pilgrims get to Cape Cod, it was goodly wooded to the shore. In the 1600s yet, it is deforested. They are cutting the trees in part to boil water, to make salt, to pack cod, to ship to England for trade goods. And they deforested the whole thing. And the government came by and said, we are so distraught that there's no trees and the soil is blowing away and it's washing away. And what are we going to do for fuel? That we will outlaw your own right to cut your own tree on your own property. When the scarcity hit, the government got in your face. So the idea that we wait till the scarcity hits and then look for something else, if you don't like government control, you may want to avoid getting into the crisis. If you ask what happens when you have a civil war in Syria and people get mad and then they bomb things and then the government wants to listen to your phone calls, maybe avoiding crisis is a nice thing to do. And then there's the other pieces of this. Things, I try very carefully not to advocate any particular policy. I want people to take the scholarship and then use it to formulate good policies. I have worked with a whole lot of good people, and some of them are economists, and the economists like to tell the following story. They don't tell it quite this way, but they tell this story. And the story is, we tax cigarettes. And we do that to raise money for the government and to reduce smoking. And we tax alcohol. And we do that to raise money for the government and to reduce drinking. And we tax your paycheck, your income. And we do that to raise money for the government. And if there's an economist in the room, please say, and reduce working. Because by making work less valuable to you, you do other things. If I needed help with something and I find a few students here and I say, look, I need a hand, I'll give you $10. They might help me. I say, look, I need a hand, I'll give you $5 and I'll give the government $5. They might not. Okay? And so at some point, the economists have said, what would happen if we taxed changing the climate? And we used that to raise money for the government to reduce changing the climate. And we took that money and we reduced the tax on your income, dollar for dollar. Okay? And what the economists say is that broadly, if everything else I said is an evil lie, that does not hurt the economy. Replacing fossil fuels is hard, and it is going to distort things, and don't kid anybody. But replacing willing workers is also hard, and that distorts the economy. And so broadly, that's a wash, or it may even help things a little bit, if everything else is an evil lie. But it's not. Now, which one is more government intrusive? A little tax that rises each year on oil, coal, and gas where they come out of the ground or into the country, or a tax on every payment to every worker in the nation? The first time I testified to a subcommittee of the U.S. Senate, it was chaired by a Republican who wanted us to scare the crap out of people so that he could put a price on carbon and avoid what's happening now, which is lots of government regulations. And the lesson was very clear. The conservative way to deal with this is to make a price signal and get the heck out of the way. So all of the sort of truisms, you know, this must lead to more government. No, it doesn't have to. It does if it's done wrong. But if you really want to reduce government intervention overall, taking wise actions now to reduce the threats and taking them in ways that reduce government intervention might actually minimize government intervention. So if you really were a libertarian and you really sort of hate that you and your kids and your grandkids will be under a government's thumb, you probably want to deal with this. And that, I think, is very important, that the knee-jerk, oh, that means the government must tell me what to do. No. Now, be honest, a carbon tax hurts poor people more than rich people, because poor people spend a larger fraction of their income on fuel, even if the rich people have a yacht and a private jet. But there's ways to deal with that. And so, you know, it's not as simple as I just told you, you need a carbon tax with an income tax drop. But there's a lot of economists who would say, hey, that will go a long way to fixing the problem without growing the government.
May I? Thank you. Tell us your thoughts about the future of fracking, not only in the United States, but in Poland and offshore Israel.
Right. So future fracking, I presume you all know fracking at this point. Algae grew in the ocean, they died, they got buried in mud, they got buried deep enough that they got hot, they got cooked, that make it oil and gas. The oil and gas float out of the rocks and they get trapped somewhere, and oil companies got really, really smart at drilling into the places they got trapped and getting the oil and gas out. And most of them seeped up to the seafloor and were eaten by bacteria and disappeared. But some of it is still left in the rocks where it started. And so you drill down to it and you drill along it and you break it, and then you can suck some out of the original rocks. This is actually, fracking is a very old idea. John Wilkes Booth was engaged with fracking. Okay, so John Wilkes Booth, before the Civil War, before he shoots the president, is an investor in one of the early Pennsylvania oil wells. The oil well is flowing oil, he is making money, he is happy. Somebody convinces them to shoot the well, which is putting an explosive in to try to frack it to get more oil out. They destroy the well. It is a very, very dotted line from there to shooting the president, but losing his income stream probably did not make him happy, okay? The next act is during the Civil War. There's a guy named Roberts, he's a Union soldier. Both sides had explosive munitions, so the cannonball would blow up after it hit. He's hunkered down in the trench, the cannonball goes over his head, it embeds itself in the dirt, it blows up and it breaks the dirt, and he goes, yes, that's how we should shoot the wells. He invents the Roberts torpedo after the war, which puts the explosive charge in a shell that drops to the bottom before it blows up. So we have been fracking for a very long time. What's new is figuring out how to drill horizontally in many places really fast and cheaply enough that you can do this, and then squirt stuff in that props open the cracks you make, and then squirt stuff other in that kills the bacteria that would eat what you want, and squirt other stuff in that lowers the surface tension so the bubbles don't get. It's sort of like simethicone for your belly. You know, they have to put in anti-gas antacids in the fracking. And so this business very clearly works. And it's very clear that it's going to be done a lot of other places. How much they'll get out, there's still a lot of organic crud left in those rocks. Right now, it's pretty clear you frack them, you pump some out, and then it quits. And then you go back and you try to refrack it, and how much they'll get, how clever they'll be, we don't really know. But you're going to see more of it, but there's still nothing in this. The sort of long-term estimates that by the time our students are old, we're going to be pushing up against limits, included the carbon that's coming out of fracking. That was already a part of the picture. So this buys time, but it doesn't buy lots of time based on anything we know so far.
Richard, is this on?
Yep.
Joel Briscoe. I'm a member of the Utah House of Representatives. I'm really happy you're here. Someone I went to Citizens Climate brought in a woman from Texas Tech. What's her name?
Catherine Hayhoe.
Catherine Hayhoe.
She's great.
I've been communicating with her. She recommended I read Jerno Wagner, who works with the Environmental Defense Fund. And in one of the chapters of his book, he said one of his fears is that someone might try and preempt all this work we're doing by shooting some aerosols into the upper atmosphere and just try and bioengineer our way out of this climate change. Would you speak to that, please?
Right. So there's no question that if you block the sun, it gets cooler. So, and we see this when there's a giant volcanic eruption, it blocks the sun and it gets cooler the next year. And you can do the math, and the simple act of flying around in the stratosphere, putting that up, is in the billions a year, but not tens of billions probably. So in terms of engineering solutions, we could block the sun enough to cool it off some fairly easily. There's a huge number of buts. One is this is not just anti-CO2. It will bring drought to a lot of places because the direct sunshine on the ocean surface is important in evaporating water, so you're gonna spin up some droughts. It will not do anything about stopping ocean acidification. That runs on. It makes it a little worse. It may hurt the ozone some. It commits to, if we burn it all, the CO2 is going to be high 10,000 years from now. It commits us to doing this for times which are long compared to the history of civilization. Or you get an abrupt climate change, the likes of which the world has not seen. Because when the system breaks, wham, they get everything that they've been blocking. It also commits to a level of international agreement and collaboration. If you're doing this by flying around in the stratosphere with a few 747s, and somebody gets a drought, and they get mad at you, they can shoot them down. And the people in the U.S., some of the people who are really excited about this idea, tend to be really not excited about the UN telling them what the temperature is going to be. And without sort of an international agreement on whose hand is on the thermostat and where it's set, this can be broken at any time very, very easily. There's a classic story we tell in Pennsylvania that's very close to this. Back in the 60s, the orchardists down along the Mason-Dixon line lost a crop one year in a hailstorm. And this was when people were excited by cloud seeding. And the cloud seeders came by and said, we will seed the thunderstorms and stop the hail next year. And the orchardists paid them. And they seeded the thunderstorms, and there was not a big hailstorm that destroyed the orchard. And a drought arrived. Now, none of these are related to each other. The hailstorm was not stopped by the cloud seeding. The drought was not caused by the cloud seeding. But you read the old newspapers, and they actually say the dirt farmers got mad. Dirt farmers is in the headline, you know. And the dirt farmers say, if you seed the clouds, orchardists, we're going to poison your wells and cut your trees. And the orchardists say, but we love not having the hail wipe out our orchard. We're going to seed them. And there's this big fight. A professor from our school went down to explain it to him. Somebody shot a hole in his car door. There is a law on the books that limits our ability at Penn State to do research on cloud seeding because of this. After that, there was another to do. They're secretly seeding the clouds after dark. Right? And this was over a little thing locally, but is the whole world going to agree to put somebody's hand on the thermostat for the next 10,000 years to block the sun by flying around?
Professor Ali, I'm Dave Fallon. I'm a volunteer with the group that Representative Briscoe mentioned, Citizens Climate Lobby, and I appreciate you mentioned the need for a tax on carbon and the values of that. We're a volunteer-based organization that is developing the political will to do that, and I think as people in Utah know, there's a lot of will now to keep digging up our resources here in Utah as well as around the world. So if any of you are interested, we have a table out front, and we invite you to come and talk to us because we really need the political will. Right now, we don't have one member of Congress from Utah who is in favor of what you said, a tax on carbon or a fee on carbon. So thank you very much for mentioning that.
Yeah, so it's a very interesting thing that I say 12, 13 years ago, the conservative way was to price carbon and to keep the government from making regulations. This sort of, the conservative side doesn't want to deal with this. It's a very recent thing. And this may be a controversial topic here, but I'm going to mention it anyway. That day when I was testifying to the Senate in 2003 and a Republican wanted to price carbon, If you would ask anyone in that room whether any of us would ever live to see any two people of the same sex get married anywhere in the U.S., we would have laughed at you, because it was completely inconceivable. And so what is politically 100% certain can change completely in a decade. And it changes by the attitudes and the thoughts of a lot of people having a discussion. And so wherever we are right now, and however entrenched anything that any of us are doing might seem, we are much more flexible than one might expect. There's some fascinating studies of people say that they're fans of this soccer team for life. And a few of them are, but the great majority just switch team to team, whoever's winning, and why all of a sudden they're big fans of them. And you'll see this in the NFL, and you'll see this a lot of other places. We can change when we decide we want to. And on big, important things, we can too.
Well, it looks like we've run out of questions, at least for now. So, ladies and gentlemen, please join me in thanking again Dr. Richard Alley.